Add, subtract, and multiply polynomials. Not a lot new here. We're just going to have some bigger ones. So I want you to think, before we do some of these, try to answer this ahead of time. Make a guess, make a conjecture. When you perform each of these operations, how will the degree of your answer relate to the degrees of what you started with? Is it going to stay the same? Are they going to get bigger? Are the exponents going to get added or multiplied or what? So I want you to try to make a guess on each of these problems before we do them. Add and subtract polynomials, not a huge deal, not a huge difference. We've been doing this forever. If I have 2x cubed minus 1 plus 2x plus x squared minus 3x plus 4, we just have to look for like terms. Now this one that I happen to give you here, there's no like term with the 2x cubed. So we just have 2x cubed. And I'm just going to, lightly cross through that. Can't lightly cross through with that. I'll lightly cross through that because I used it. Now I'm going to look next thing in line because I want my answer to be in standard form. So I'm going for the next highest exponent. X squared. Now these two I have to combine. I have 2x minus 3x, so negative 1x. And then my constants, negative 1 plus 4 is 3. So not much new there. One thing I will say is you might like to try vertically aligning them instead of just leaving them horizontal. Some people like this. So you'd write this in standard form, leave a space for the x squared, and then x squared minus 3x plus 4. So then, you're just adding down 2x cubed plus x squared minus x plus 3. So that's just an alternative way to do it. I will say, just as previously said, when you're doing these and when you really all you have to do is combine like terms, once you get into an addition problem, I would distribute the negative and then just rewrite it as an addition problem. So my 5 becomes negative, my 6 becomes negative, my 8 becomes positive. And so again, you can just pick out your terms left or right, or this is a good candidate for, I might as well just write this down below here. There's no cube term. So as long as I'm going to rewrite just half of it, I might as well do that. So I've got 4x cubed minus 13x squared minus 4x plus 5. Now what about multiplication? Well, we spent a lot of time multiplying polynomials, but we were only doing binomials. So again, if I say to multiply this, we've been doing that to death, but what if I give you a third one? Well, all you can do is multiply 2 at a time. So I would do the first 2, again, you can do FOIL, I'm going to do the box. So we've got x squared minus 2x minus 15. Now I've got that times the third one there. So now I just need another box. This time it's going to be a trinomial and a binomial. So 2x minus 5 and our x squared minus 2x minus 15. So I've got 2x to the third minus 5x squared minus 4x squared plus 10x minus 30x plus 75. So whenever you have these varying degrees, those guys are going to get combined and those guys are going to get combined. So our answer is going to be 2x to the third minus 9x squared minus 20x plus 75. So I could do another example where I give you a binomial and a trinomial, but we already did that in the midst of this example. If this is the question, this is the answer. If they happen to give this as the question, that would still be the answer, right? So in any case, if you have to do more than two polynomials you're going to multiply, all you got to do is 2 at a time. And when you have a different number of terms in your polynomial, just make sure you make the box the right size. Those are the only tips I have. So think, now that we've done some, predict when the degree is going to change and when it's not and how it's going to change. It's important to think about that ahead of time because lots of people make mistakes with their exponents when they're adding versus multiplying, multiplying versus adding.